please.
Good morning, everyone. My name's Abhi, and today Group C will be presenting our design progress for the wing and ground effect project for this semester. Before I start, I'd just like to mention that all members of the group are present here today. So this is the design that we've come to at the moment. It's a blended wing body design, and it was taken up mainly due to us trying to maximize the wing area and still trying to fit the craft within a single berth at Port Phillip Bay. So this we hope to reduce the parking costs and make it more marketable in the future. The cockpit is similar to a luxury car, and the canopy opens like a Miles Leopard canopy. This is a single engine variant that we've looked at, but due to CG location and also because we don't want to be stuck in the middle of the water if one engine fails, we've sort of put it on the back burner at the moment. The craft will be operating as a high-speed vessel in ground effect, but it will not be leaving the surface of the water. These are just the composition drawings for our final design. As you can see, the actual overall dimensions will fit within an 8.5 meter by 5 meter box, which is a single berth at Port Phillip Bay. So that's what we sort of try to size around from the start. Some of the implementations that we've included that changed from last semester was dipping rudders. We've got new pontoon shapes that came about from some of our RC testing, and we've also got ducted fans and a box tail design where the actual vertical tails also act as winglets. This came about from our wind tunnel testing, and we've got a larger horizontal tail than what was initially expected, and this was mainly due to unstable pitching moments in ground effect that we found in our RC testing. This is just a structural drawing. We've got 4 ribs and 4 booms at the moment, and the actual skin itself is going to be made from a foam between composite sandwich structure, and the booms and ribs will be just composite laminates. So we've got there's 2 ribs on each side of the cockpit and 2 at the edges at the moment. And I'll just pass you over to James now.
Thanks, Abhi. Okay, so basically performance parameters with our craft. We're looking at an L over D of roughly 6.6. That's from testing from our wind tunnel testing. We're looking at limiting the maximum cruise speed to 110 kilometers per hour to ensure fast but smooth planing during operation. We're also looking at a travelling time of 34 to 38 minutes between Geelong and St Kilda with that speed. So in our propulsion system and range and endurance, we've got 2 Limback aero engines, 84 horsepower each, 28 litres per hour for the fuel consumption, which is giving us around about a range of 360 kilometres per hour, 360 kilometres, or an endurance around 3 hours. So this is basically the CG or mass breakdown. The trouble with the blended wing body construction was that it's unstable due to the CG being after the aerodynamic centre of the wing. There's not enough real element structures to hold the weight in front of the wing, and therefore it was hard to make the CG go before the aerodynamic centre. This step, as you can see, is step hull. This step is located just after the CG to help for planing purposes. I'll just pass you over to Kiros, who will talk about the design implementation.
Thank you, James. So we had 3 areas, 3 technical areas. The first one was wind tunnel testing, the second was RC model testing, and the third market analysis. From the wind tunnel testing, we found that we needed a larger tailplane for stability reasons, and winglets were added for L over D ratio improvement. As you can see that the box was designed at second design. From the RC model testing, we modified our pontoons to have a flatter and a wider bottom, compared to the first design where you had a narrower and deeper shape. We found that the second design actually lowers our planing velocity. Dipping and kick-up rudder hybrid design was implemented. A dipping rudder is basically how maneuverable you want your craft to be, then how deep the rudder will be immersed in water. That decreases drag. And a kick-up rudder is basically a safety mechanism where the rudder kicks up upon impact. And from this test, we concluded that our design is more suitable to be a high-speed marine vessel compared to a wing and ground effect aircraft. Finally, the survey analysis directed us towards a more recreational use instead of a commuting one. As you can see from our results, about 75% of businessmen actually prefers to travel by car, and majority of the general public prefers to travel either by car or train. That's why we have concluded that the commuting market is not feasible, and we are targeting the recreational one. And now I'll pass you on to Komal to talk about the RFP requirements.
Thanks, Kiros. We were able to meet majority of the RFP requirements, but these are the ones listed on the slide now are some of the requirements that we didn't touch on. We basically didn't have the time to go into these, and the focus was on some of the other key requirements. These are the requirements that we failed to comply with. Well, it's a high-speed watercraft, so there will be contact with water at all times. It's not a wing and ground effect aircraft. It's a recreational craft, and the travel routes are not restricted to Geelong and Kilda. The cruise speed dropped down to 110 as opposed to the 150 required. It will fit in a single berth, and which is smaller than a double garage, which is what we've restricted the size to. The fuel consumption of the German engine we're using is more than what was required. Now let's watch a small video of the RC model testing. Well, that's the video, and that concludes our presentation. Thank you, and we'll take questions.